Okay, so I'm going to do 4, 6, and 13. The first thing I notice is that both 4 and 6 are quadratics. There's an exponent of 2, which means the maximum number of answers we're going to get is 2. So we can possibly get 2, 1, or 0. As soon as I see this, I want to set this equation equal to 0. So I'm going to subtract that 120, which turns this into 4x squared minus 28x minus 120, and that's equal to 0. The next thing I want to do is always look for a GCF. Remember, when you're factoring, if you can take a number out and make your other numbers smaller, that's what we want to look for. So I'm going to factor this 4 out, and that goes in front of the parentheses, and what I'm left with is x squared minus 7x minus 30 is equal to 0. Now I use the guess and check method. So what I do is I ask myself, what multiplies to make x squared? Okay, and those are my first two numbers, and I know that's x times x. Then I ask myself, what multiplies to make negative 30? So again, this is a guess. I'm guessing right here. I guess on the blue, I guess on the orange, and then we're going to check. So what multiplies to make negative 30? Negative 15 times 2, negative 2 times 15, negative 10 times 30. I'm going with negative 10 and positive 3, not 30. And then to check this, you would multiply the inside 2, negative 10x, and the outside 2, which is a positive 3x, and those two together add up to make this negative 7x. So it does check out. My factors, therefore, are 4 times the quantity x minus 10 and x plus 3 is equal to 0. Set each of these equal to 0, and when you do that, you get x is 10 and x is negative 3. And if you take those, plug them back in up here, I guarantee those will work, okay? But you always want to check your answers. Number 6, we're going to start the same way. Let's take out a GCF. I'm looking at these, I see they can each be divided by 5. So we're going to take that 5 out. We're left with 9x squared minus 12x plus 4 equals 0. As I'm doing this problem, I notice that the first term and the last term are both perfect squares. So in my mind, that's kind of, like, ooh, 9 and 4, those are perfect squares. So when I use the guess and check method, I'm going to factor the 9 down, and I'm going to factor it down to 3 and 3, and we'll see if this works because it's a perfect square. You can also choose 9 and 1, but my assumption is 3 and 3. Next, what multiplies to make a positive 4, but the difference is I need a negative inside here, so I know that negative 2 times negative 2 also gives me a positive 4, and when I check my answer, negative 6x, and this is the step I want you guys to practice in your head, negative 6x, and that makes a negative 12x, which checks out. There are your factors, so obviously we're going to have that double root, so set that equal to 0, and you get x equals 2/3. Okay, so in this case, our discriminant is equal to 0. We only have one x-intercept. And that brings us to this problem. Which ones are going to have a double root? So again, a double root is when the discriminant, b squared minus 4ac, is equal to 0. Okay, if the discriminant, that means a double root, that means you're going to have one solution. Double root just means that the answer is going to be the same for both roots. So I'm going to pick out my a, which is 1, my b, which is negative 4, and my c, which is k, and we're going to plug it into here and we're going to solve. So b squared minus 4ac equals to 0. 16 minus 4k equals 0. If you go through and solve it, you get k is equal to 4. Okay? If you go back to the original and plug it in, and then if you factor this down, it turns into x minus 2, and there's your double root. So you know that your k value is 4.